Good day everyone, I am Mitchpan Casil and today I will demonstrate the part of the turning circle, which is the advance. So advance is the forward motion of the ship from the moment that the vessel commences to turn. So it is the distance traveled by the vessel in the direction of the original course from the commencing the turn to the completing the turn. So advance is measured from the point where the rudder is put hard over, which is this point, up to the intersection of the line at right angles to the original track to a point where the ship has altered heading to 90 degrees.
So as you can see, the advance is measured from this point, where the rudder is put hard over until this point, where it intersects in original track of the vessel. So this is like measured in 090 degree. So that's the end of our topic. Let's proceed that next reporter.
Good day sir, I am Midshipman Ares. I'm gonna demonstrate the transfer. So makita natin dito yung picture, no? So ang transfer is the distance while a ship makes a 90 degree. So nakita natin tong 90 degree change of heading. So for more definitely, it's a distance between the original direction vector of the ship and the point when it's completely headed starboard and its second phase of turn. So makita natin dito no sa picture na lumiliko na siya to 90 degrees of heading. And the following figure illustrate more better. So thank you.
Good day, I am Aligata Gangenji from NS3A3 and I am now demonstrating what is transfer. Rule number 6, safe speed. Every vessel shall at all times proceed at safe speed so that she can take proper and effective action to avoid collision and be stopped within a distance appropriate to the prevailing circumstances and conditions. Rule number 6, safe speed A3. The maneuverability of the vessel with special reference to stopping distance and turning ability in the prevailing conditions. Let's look a little bit at stopping distance and your vessel is out of course from the time the order given to stop the vessel dead in the water to the time the vessel actually stops in the water is called head reach. Head reach is one of the factors in determining safe speed. Turning ability, when you're gonna make the turn, from the time you start the turn until the time is completely done, we have in the direction parallel to the original course, this is called advance. And in the direction perpendicular to your original course, this is called transfer. Transfer is the distance moves away from our original line of advance. When altering course, under helm is measured along a line perpendicular to her original course and to the point where she is on her new course.
Good day. I'm Midshipman Luciano Christopher S. from NS2C1. The topic is tactical diameter. Tactical diameter is the transfer for a turn of 108 degrees, which is almost equal to the max transfer and about the maximum advance. The diameter will vary based on the speed, the amount of rudder, shoes, and the trim. Yes. When the vessel trimmed by the astern, the tactical diameter is increased. When a vessel is trimmed by head, the tactical diameter is decreased. The vessel with a lease will take longer to execute the turn, and when the turn into the lease will develop a large circle. The vessel with right-handed turn propeller, if making a turn port, will end up with smaller diameter than starboard due to the effect of the transverse thrust. That's all. Thank you.
Good afternoon, everyone. I'm Midshipman Mark Grayson Argulang from NS2C1. So now we are going to present how the tactical diameter used on ships. So let's go. So the tactical diameter, as you can see, that the vessel is armed. For the previous example, it was the only originally hitting the 00 degrees, that it has changed to 090 degrees, and then it is changes further by 90 degrees and became 180 degrees. So tactical diameter then becomes the measure of the extent of turn our vessel. So in this case, you can see that it is measured as the distance of the separation between the original direction vector of the ship when it was steady of a steady heading of 000 to that in the final turn. When the steady state is achieved, that it is when the ship changes heading by 180 degrees. So in other words, the distance are negotiated in a completed turnaround of at a constant rudder reflection is determined by this length. So as the distance is almost equal to the geometric diameter of its path, it's called the tactical diameter. Now the tactical diameter is often prescribed as equal to be 4 to 5 ships length between the perpendicular, or 4 to 5 ships length overall, rather so, but depends on your vessel of course, but it is somewhere around that range.
Good day everyone, I am Midshipman Joshua Allen Aguilar, and today I will give you the criteria and assessment number 4 of assessment number 2. Analysis of drift angle observed and gathered during the simulation and conform to the model of the ship in drifting speed. Now we see in my video that we have the straight line of a ship, a course of a ship. Now we can set our ship in drifting motion using our bow thruster, starboard or port bow thruster. Now if we set our bow thruster, starboard bow thruster, we clearly see that our new path is changing into a new path, and then using our starboard port side bow thruster, and it's changing also the new or giving us to a new path of the ship. Now clearly we see our new ship heading course now in a straight line, and the tracking of our ship into our new course or new heading. But what if we release the starboard bow thruster into 00 degrees? We can clearly see in the video that our ship is creating a new path or new course. This is because our ship is in a drift angle motion now. That's why when we release our bow thruster, it creates a new path for the ship, and that is the effect of the drift angle and drifting speed into our ship.